A New Angle on Global Wind Measurements, presented by Science at NASA. Summer can bring with it a whirlwind of activity. Hurricane season causes potential havoc on land with threats of forceful winds and torrential rainfall. A helpful set of eyes mounted on the International Space Station allows scientists to observe these massive storms from a special angle, 51.6 degrees to be exact. That is the inclination of the space station's orbit around Earth. NASA's ISS Rapid Scatterometer, or ISS RapidScat, was launched and fixed to the space station in September 2014, giving it a view of the planet below that differs from any other wind measuring instrument. Brian Stiles, ISS RapidScat Science Processing Lead at NASA's Jet Propulsion Laboratory, says, because of its inclination, RapidScat observes storms in higher latitudes much more frequently than polar orbiting scatterometers. The same location can be observed several times per day, and this lets us see how storms are developing in more detail. The data that RapidScat provides is being used by NOAA to support marine weather forecasts and warnings, providing better observations of storms as they intensify and weaken. Zorana Jelinek, RapidScat project scientist at NOAA, says, RapidScat observations greatly aid in our ability to study temporal changes of wind fields. When observations are available, we have the ability to study changes within 1 hour at high latitudes. Previously, we were only able to characterize changes every 6 hours. In the tropics, RapidScat has improved the wind coverage of the space-borne scatterometer constellation from once every other day to more than once a day on average. ISS RapidScat is a radar, bouncing microwaves off the ocean surface and measuring the echo. Rough waters, those disturbed more by wind, return a stronger signal than smooth waters. From that information, scientists can derive wind speed as well as its direction based on the orientation of the waves. RapidScat excels at measuring winds at the ocean surface, adds Stiles. Measurements of surface winds are important for many reasons. For one thing, surface winds define how the ocean and the atmosphere interact where they meet, which influences weather in the short and long time scales. Moreover, surface winds are what boats experience at sea, and people and buildings actually experience when a storm makes landfall. RapidScat provides remotely sensed ocean surface wind speeds and directions. With such a huge void of radar and surface observations over the oceans, remotely sensed ocean surface winds play an instrumental role in marine decision-making, forecasting, and modeling. Stiles says this is useful information for both weather forecasting and climate studies. Since it was launched, ISS RapidScat has seen dozens of storms, big and small. Maps of surface winds have given Earth scientists a unique view of the inner workings of these storms. The orbit of the space station covers the majority of the oceans from southern Canada all the way to the southern tip of South America every 48 hours. This means few storms escape RapidScat's relentless microwave scanning. These advantages are enticing weather forecasters and climatologists to make increasing use of the high-resolution wind data that ISS RapidScat offers. The information from these data are being utilized by marine forecasters at NOAA to help forecast, warn, and analyze wind and wave conditions over the ocean environment, from hurricanes and windstorms to fair weather conditions. Improved knowledge of impending wind and wave conditions impacts everything from large cargo ship routing to recreational boating to families vacationing along the coasts. As summer unfolds, ISS RapidScat will have a lot to do. For more from the International Space Station, go to www.nasa.gov/station. Stay tuned for updates from science.nasa.gov.